Hi, welcome to the screencast on writing loops with Mathematica. Loops are useful for any procedures that need to be run over and over. For example, most computational algorithms use some type of loop to perform their calculations. A for loop is typically used when you know how many times you plan to execute or run the loop. We're going to start with a really simple example so you can see how the Mathematica for loop syntax works. Let's say I wanted to print the numbers 1 through 5. The for loop in Mathematica is treated like a function with a capital F. Within this function, Mathematica expects four things: the start, the test, the increment, and the procedure. The start is the initial values of the variables in your loop. For us, it's going to be I equals 1. That just says this variable is set equal to 1 before the loop starts. The test is used to decide when the loop should stop running. For example, if we wanted to stop the loop at I equals 5, we should make the test something like I less than 6. That is, we stop running the loop if I reaches the value of 6. In the language of loops, I is called the loop control variable. The increment is how the loop changes the loop control variable after each execution of the loop. In this case, we want to increase I by 1, so we'll type I++. This syntax is borrowed from C++, but it just says add 1 to the current value of I. Finally, we get to the procedure. This is what the loop executes in each iteration before the test fails. For us, we just want to print the value of I. We can run this and we see that we get a printout of each value of I from 1 to 5. I want to highlight here the commas between the different parts of the loop. That's how Mathematica understands which part of the loop you're working in. Now we can make this loop a little more complicated. Let's say in each iteration we wanted to use I to compute something and then print that value. For example, maybe we wanted to print the function x of I is equal to cosine of I. First, we want to make sure to give x an initial value. So we'll type semicolon x equals 0. This is just good programming practice to initialize your variables. Mathematica understands the semicolon as separating things within parts of a loop. So the comma here separates the initialization from the test, and the semicolon separates different initializations. So semicolons allow you to put additional statements within the different parts of your loop. We'll see that again right here in the procedure. So we want to compute the value of cosine of I and assign that to x. So we'll type x equals big N bracket cosine of I. Now the big N here just tells Mathematica to numerically evaluate the cosine of I. Notice that I typed the semicolon to separate the two different parts of the procedure. Now I'll replace the I with x, and now we have a loop that loops through values of I, computes the cosine of I, stores that in x, and then prints it. So we'll just run that, and you can see we get values for the cosine of I from I equals 1 to 5. So that's a very simple introduction to using a for loop in Mathematica. And believe me, there's much more that you can do with for loops, and you should check out the documentation on for loops in Mathematica. And also, I would suggest searching the internet for some interesting examples. This concludes the screencast on using for loops in Mathematica. Thanks for your time.